Hello guys, welcome back to my channel. In today's video, we will walk through another example problems regarding the structural analysis. This problem is different from the previous one, the one that we solved regarding the trusses. But here is different. We have the problem is the hoist support, the 125 kilogram engine, as shown in the figure. We have it here. So we are required to determine the force the load creates in member BD, which is a diagonal member, this one, BD, and the member FB, which is this one, the diagonal members where we have the hydraulic jack in here, which contain the hydraulic cylinder H, which one is one here. So if we look at in the figure, we have the pre-body diagram. We have the vertical reaction at point A and also at point C. This is the vertical reaction due to the well A and well C. So we have the vertical load due to this the weight of this engine, which is P. So the frame is in equilibrium. We'll assume that this is at rest, so that we can calculate the moment. All the summation of forces are equal to 0. So by the way, guys, at the end of the this video, after we solve this problem, I will give you one bonus problem that is similar to this for you to solve as an exercise. Okay, let's proceed to the solution. So determine the load P. First of all, we have to determine the load P here. So the load P actually is only 125 kilogram engine. Since it is in kilogram, we will convert it into Newton. We have to multiply it by 9.81 to become a force. So 1.23 kilonewton, that is the equivalent in kilonewtons. Actually, this frame, if we segregate all these members, we have a total of 5 members. 1, 2, 3. So these 2 members are all bracing. So if you can see here, this is the these are all the members. If we separate, if we dismantle it from the frame. So next one is to determine the axial load FB. So this is the load that we are going to determine, this load. What is the axial load of this member FB? So to solve that, first of all, we need to separate this member. If we detach this member from the frame, so all the forces that we have is, we have the FB axial load here, and the corresponding component, we have the FBY and FBX. So FBY is equal to FB times 3 over 3.16. So that is the vertical component for axial load FB. So this is actually the slope of this member. We have 1 meter and 3 meter. This one here, from here to there, 3 meters. So if we sum up moment at E is equal to 0, assuming that the frame is at rest. So if we sum up forces along Y, we have 2 unknowns here. If we sum up moment at E, the only unknown that we have is only the vertical component of FB, which is FBY. So if we summation of moment at point E is equal to, let's say, positive moment clockwise, positive movement clockwise. So P is with respect to point A, that is counterclockwise. So negative P times the moment arms, 3 meters from here to there. 3 meters, plus vertical component of FB, which is 3 over 3.16 meters times the moment arms of 2 meters from here to there. So the only unknown is FB because P is already given. We have already calculated that one. So FB is 1.94 from this equation. So this is the final answer of FB. This one here. FB. So the other member that we are going to determine is BD, which is the diagonal BD from here to there, this member. So, okay, continuing on. This is the pre-body diagram. Then we will determine the reaction load at the support. The action load from the external load, which is 1.23, the load from the engine. So if we sum up moment at point C, we have only one unknown, AY and P. Okay, so AY is times the moment arm is 3 meters from here to there, minus counterclockwise the load from the engine above, which is counterclockwise, so negative 1.23, the load P, times 3 meters from here to there, and that is equal to 0. So the answer is 1.23 kilonewton. Next one is to determine the load, axial load dB. So this one here. So how to determine this one? So if we segregate these members from the frame, the forces that we will have is this one. It looks like complicated, but if you examine this forces, all the forces at point B, this forces is from this load here. We have determined that already, which is 1.94 kilonewton. So this is the slope, and this member is 45 degrees 1. So the slope is 1.41, 1:1. So now if we sum up moment along vertical forces, we have two unknowns here. We have FB and the FY, AY, but AY is already given here. But we have CY, another unknown. So I think it's better to sum up at moment C so that the only unknown is only dB. So if we sum up moment at point C, we have only a vertical component of the forces dB, which is dBy. So dBy is equal to dB times 1 over 1.4. That is the vertical component. Now, with respect to point C, so 1.23, which is EY, times the moment arms 3 meters, minus the vertical component of FB, which is 1.94, times the vertical component 3 over 3.16. This one here, 3 over 3.16, times the moment arm 1 meter, then minus dB, counterclockwise, vertical component is 1 over 1.41, this one, 1 over 0.41, vertical component, times 1 meter, okay, equal to 0, equilibrium. Now, the only unknown is dB, so dB is equal to 2.6, and that is the final answer of our problem. So the next one, guys, is the bonus questions. This is a very similar problem. If you solve that problem, I don't have any reason that you cannot solve this one, because this is very similar problem. So this problem is determine the resultant forces at point B and C on member ABC. So for the 4-member frame below, it's just a reaction. What is the reaction of that? So I will just leave that problem to you guys for you to solve, and maybe you can confirm your answer. We have the answer here. If BE is 1.53 kips, and if CD, this one, the reaction at this point is 0.35 kips. So if you find this video helpful, guys, please don't forget to subscribe and like, so that we can still make video for practice problem. So thank you guys for watching, and see you next time. Bye bye.